All right, let's start with a function. This is a function that relates the number of miles of a cab ride to the total cost of a cab ride. So just to get into the cab, they charge you $2. After 1 mile, the total cost is $5. After 2 miles, the total cost is $8. So what is the cost of each additional mile? Well, we could subtract. And what you'll notice is that the first mile costs $3. The second mile costs $3. The third mile, and so on. So what can we conclude from this? Well, this is a linear function. A linear function has a constant rate of change, which in this example is the $3 per mile. Each mile costs $3 more. And this word more is very important because to go 2 miles is a total of $8, but an additional mile is $3. So that $3 is a rate, and that's $3 per mile. The 8 is just dollars, which is a quantity. So this is precalculus. In calculus, the difference between a rate and a quantity is very important, and it's something you should really pay attention to. All right, that constant rate of change of a linear function is called the slope. And the formula for the slope is the change in y over the change in x. And in case you haven't seen it before, this is the Greek letter delta, and that's used for change. Let's look at another function. Let's say you decide to start selling tofu dogs at the local metro station. So to produce 0 tofu dogs costs $500. That's the cost of your tofu dog stand, also known as the startup cost. Producing 1 tofu dog costs $505 total dollars. Producing 2 tofu dogs is $510 total dollars, and 3 is $515 total dollars. So the question is this a linear function? And the answer is yes, because each additional tofu dog produced costs $5 more. So 5 is the constant rate of change. What are the units of that 5? Well, it's going to be the units of y divided by the units of x. So it's going to be the number of dollars divided by the number of tofu dogs, or $5 per tofu dog. Let's look at another example. All right, this example gives the number of hours that you spent in your garden weeding versus the number of weeds in the garden. So when you started out, there were 100 weeds. After 1 hour, there are 85. After 2, 70. Is this a linear function? All right, so I would hit the pause button so you can decide if it's a linear function, and then find the slope of that function and write its meaning in the form of a sentence. All right, so you subtract, and for each additional hour, there are 15 fewer weeds in the garden. So this slope is negative because this is a decreasing function. So the slope of this linear function is negative 15, and the units are going to be the units of y divided by the units of x. So that's weeds per hour. All right, let's look at this function, which relates the number of hours that you studied to the number of texts that you sent to your friend. And this would be a good place to hit the pause button while you do the calculation. All right, is this a linear function? And the answer is no, because for each hour of study, the number of texts is not the same. So you would call this nonlinear. And just for fun, why don't you take a moment and see if you can decide which nonlinear function best describes this situation. So I'd hit the pause button and think about that for a second. All right, so these are both increasing functions. They're both nonlinear because they're not a straight line. Which one best fits this situation? Well, it would be the one on the left, because you can see that the more you study, the more you send texts. So this is increasing faster. So what does that mean, increasing faster? So one of the main ideas that we're going to look at in calculus is the slope of a function that is non-linear. And what you can do is, if you look at a small enough portion of the function, it looks linear. So you can examine the slope of this function at different points. So the slope of this line, this section, and this section, you can see that these slopes are getting greater, like this function. So you would call it increasing faster, and it's also called concave up. In contrast, this function is increasing slower. So if you look at a small section of the function, so that's the main idea behind differential calculus. If you look at a small enough section of a function, it looks like a line, and then you can examine the slope of that line and figure things out. So the slope of this line, and then as the function goes on, you can see that those slopes are getting smaller. So this function is increasing slower, and this is called concave down. Concave up, you can remember, it looks like it's smiling. So up, happy. Concave down, looks like a frown. Down, sad, like that. All right, let's do another example. All right, one more example. Let's say you bought a new video game. So the first week you played 20 hours. The next week you played on it for 10 hours, and so on. Is this linear or nonlinear? So I would hit the pause button and find that out. Actually, this setup makes more sense. So this would be the total hours you've played since you bought the game. So if it went from 20 to 30 to 37 to 38, Is that linear or nonlinear? The answer is nonlinear, because each week you spend less time on it. And then just for fun, is that increasing faster or increasing slower? So you can see this is increasing slower. So the graph of this function would be concave down. All right, let's do another example. All right, find the slope of the line that passes through -1, -3, and 5, 15. So I'd hit pause and finish that one out. All right, so we just have to use the slope formula, which is the change in y over the change in x, or you can write it as y2 minus y1 and x2 minus x1, and it doesn't matter which one you call x1, y1, and which one you call x2, y2. All right, so I called this one x1, y1. So it's 15 minus -3, which is 18, over 15 minus -1, which is 6. So the slope is 3. That's positive, so that makes this an increasing function. Then you'll want to memorize the point-slope equation of a line. You'll use this version when you know a point and you know the slope. Let's do an example. All right, find the equation of a line whose slope is -2 that passes through 1, 3. So I would hit pause and try this one on your own. All right, so all we have to do is fill in the numbers. Y minus 3 is equal to -2, x minus 1, and you're basically done. Now, a lot of times you'll be asked to write it in what's called slope-intercept form. All right, slope-intercept form is basically just when you solve for y, and m will be the slope, and the point 0, b is the y-intercept. Don't make the mistake of calling b the y-intercept. It's just the y value of the y-intercept. Remember, this is a two-dimensional system, so every point has an ordered pair as its address. So if you wanted to take a moment, take that equation and solve for y. All right, all you have to do is distribute the -2. -2 times -1 makes +2. Add 3 to both sides. So the slope is -2, and the y-intercept is the point 0, 5. And the reason you would want to write a function in the slope-intercept form is that's the easiest one for graphing sometimes. So you have a y-intercept 0, 5. Slope is -2, which means the function is decreasing. -2 means if x increases by 1, y decreases by 2. And there you go. All right, let's look at another function. Is this a linear function? This gives us, sorry, I had to fix that. This gives us the number of days since the beginning of class and the number of students in the class. So I'd hit pause and see if you can decide if that's a linear function. So you calculate the slope, and it turns out that the slope is the same. So that means this is a linear function with a slope of 0. What will the graph of this function look like? Well, no matter what value x is, y is going to be 35. What will the equation of this line be? Well, the y-intercept is 0, 35. So b is the y value of the y-intercept. The slope is 0, so that's 0 times x. But 0 times anything is 0, so that's just going to be y equals 35. Let's look at another one. Right, so this function is a horizontal line. What does it look like if we have a vertical line? So let's suppose this goes through 5, 0, 5, 1, 5, 2, and so on. Well, if you try to calculate the slope of the line, you divide by 0, which is undefined. And the equation of the line, well, it's x is 5 no matter what. So that's the equation of the line. By the way, this is not a function. All right, and then just a couple of definitions. Lines with the same slope are parallel. So are these two lines parallel? And the answer is yes, because they have the same slope. And the slopes of perpendicular lines are the negative reciprocal of each other. Reciprocal, and don't call it an inverse, that's a whole other animal. All right, so if the slope of the first line is 2/3, what's the negative reciprocal? We just take the reciprocal and change the sign. So a perpendicular line to this one could be, and the y-intercept could be any number at all. So the formula for perpendicular lines is that the product of their slopes is -1. All right, so can you find the equation of the line whose graph is given? So I would hit the pause button here and work this one out. All right, so the first thing you should notice is that this is a decreasing function. So the slope is going to be negative. So just, that's a nice way to check yourself. All right, so you should be able to find the slope using any 2 points on this function. So here's a nice point. And here's another one. Or you can simply use the graph. If you go over 4, you go down 2. So the slope is going to be over 4 down 2. So the slope is going to be -1/2. And we have the y-intercept. So you can simply put it into slope-intercept point form. And then how could you check it? We could find any other point on this line, like this one. Plug it into X and Y and see if it makes a true statement. So is 2 equal to -1/2 of 8 plus 6. That's true. So we did the problem correctly. Let's do another one. All right, here's another one. See if you can find the equation of the line. So I would hit pause, try it on your own. All right, so once again, we have a really nice y-intercept. And then looking at the function quickly, you can see that it's an increasing function. So you want to make sure that your slope is positive. How can you find the slope? We'll pick any 2 points on the line. And you can either read off the particular points or just use the graph. Since the slope is the change in y over the change in x. So for this 2 points, the change in x is 3, the change in y is 2. Make sure it's positive because this is an increasing function. So the equation of the line is just 2/3 x plus 1.